Alright folks, let's do number 49. An air traffic controller observes two aircrafts on his radar screen. The first is at an altitude. Do they give you place the x west, y-axis south, and the z-axis vertically? Oh my god, okay. Well, that's good. Usually they had the j-axis vertically, but anyway, whatever. Anyways, observes two aircraft on his radar screen. The first is at an altitude of 800 meters. The horizontal distance is 19.2 kilometers and 25 degrees south of west. All right, let me draw this. So let's get started. So two aircrafts. So aircraft one, I'm gonna use my own notation as is in that vector, and the aircraft two is in this. And this is how I normally notate my when I do these. So the first point is 19.2 kilometers. So I'm going to call it R1, or in this case I already called this that. So R1 at 25 degrees south of west. So if I'm not mistaken, this is south of west. Let me double check, confirm that. So this is going to be 25 degrees at the magnitude of 19.2 kilometers. And the second is at an altitude of 1,100 meters and a horizontal distance of 17.6 kilometers south of west. Are they both south of west? Yeah, they are. Oh my god, okay. So it's going to be a little here. It's going to be a little hard to draw this, but it's going to be 20 degrees. I'm just going to exaggerate this. I'm not really drawing this to scale anyway, so at 17.6 kilometers. And the thing is asking x axis west, y-axis south. I could just call I'm going to put the right direction. So anyways, let's put the vector now. So the vector here is going to be both negative. So negative 19.2 cosine of 25 degrees. Negative 19.2 sine of 25 degrees. And that's going to be at the altitude of 0.8 kilometers. This other one is going to be 17.6 kilometers, 20 degrees, so that's going to be negative. So that's going to be cosine of 20 degrees. Negative 17.6 kilometers, sine of 20 degrees. And so this is going to be a kilometer. And there's your vector, folks. I don't know what more they want. What is the distance between the two aircrafts? And I don't understand why this is blue. But apparently people are pretty retarded these days. So anyways, so you have your two vectors. What I'm going to do is I'm going to call change of R as the difference between R2 and minus R1. And since this is a three-dimensional type problem, I don't think they're going to ask for an angle. So an aircraft controller observes two aircraft on his radar screen. The first is at an altitude southwest. The second is at an altitude of that. So we're just going to find the distance between those two aircrafts. And I'm going to take R2 minus R1. So once you find that and put it all together, so the change of R is going to be the vector is going to be 19. Oh, why did I put 19? All right. So the change of this is going to be 0.86 kilometers, 2.09 kilometers, and Z is 0.30 kilometers. So that's going to be the distance So once you put it all together, and it does match the answer to what I have, the magnitude of change of r is going to be 2.28 kilometers. And this was pretty easy problem, to be honest. I don't know why people are finding this hard for some reason. I don't understand people. People are weird. Anyways, folks, I hope this helps.